Hey everyone, today we're going to discuss about graphing inverse functions. So in our earlier video, we've learned that we can obtain the inverse function if the function that we're dealing with is a one-to-one function. Now let's observe what will happen if we graph an inverse function. Now, the graph of the inverse is a reflection of the graph of the original function. The axis of symmetry is the line y equals x. What do we mean by this? Let's have an example. Let's have disordered pairs 1, 2, 3, 4, 5, 6. So let's plot it here. So we have 1, 2 right here. 1, 2. We have 3, 4 right here. And 5, 6 right here. Now, let's get the inverse of this 3 ordered pair. So the inverse would be 2, 1, 4, 3, and 6, 5. If we plot it, it's right here. 2, 1, 4, 3, and 6, 5. So these 3, I'll label it with blue. These are the points from the original function. And those that I will label with red are those from the inverse. Now, the axis of symmetry is the line y equals x. So let me type y equals x here. So here is it. Here's the line y equals x. Now what we do is whenever we graph an inverse function is that we just get the reflection of the original function. So it's right here. Then you imagine like it rotated along the line y equals x. So from here it went to this side. Here it went to this side. And here it went to this side. This is consistent for all functions whenever we get the inverse. Its axis of symmetry is the line y equals x. Okay, let's try graphing a function and let's also try to graph its inverse. So let's have f of x is equal to 2x plus 4. So let's try to graph. Take note that the slope of this function is 2 or 2 over 1. Then the y-intercept is 4. So we start with 4. Then rise over run. 2 units up, 1, 2, and 1 unit. So it's positive to the right. So we have 2 points, this point and this point. So we draw a straight line in order for us to graph f of x is equal to 2x plus 4. So right there. This is the graph f of x is equal to 2x plus 4. Okay, let's erase. Now, let's try to obtain the inverse of this f of x. So let's have y is equal to 2x plus 4 and reverse the x and y. So this becomes x equals 2y plus 4. Transpose the 4 to the other side. This becomes x minus 4 is equal to 2y. Then let's divide both sides by 2. So this is x minus 4 all over 2 is equal to y, or y is equal to x minus 4 all over 2. We can separate the fraction here. So this becomes y is equal to x over 2 minus 4 over 2. This can be done on any fraction. Let's simplify 4 divided by 2. So this is y is equal to x over 2 minus 2. Since x over 2 is 1/2 x, so we'll just write it that way. Minus 2. So this is now our inverse. So let's replace y as f inverse of x, or the inverse of f of x. So 1/2 x minus 2. Therefore, the slope is 1/2 and the y-intercept is -2. So let's graph it right here. So let's start with y-intercept as -2, and since the slope is 1/2, 1 unit upward and 2 units to the right. So we connect these two lines, 2 points here. Let's just type. So this is 1/2 x minus 2. So this is the graph. G of x is equal to 1/2 x minus 2. So that's the graph. And observe that they intersect at this point. Now let's input here y equals x. Remember that y equals x is the axis of symmetry of the function and its inverse. And as we can observe here, the graph looks like it rotated from here going to this side, on the other side at this point. So imagine it being rotated at this point here. So that's what the line y equals x does. It serves as the axis of symmetry between the function and its inverse. This property is consistent for all functions that are one-to-one and its inverse. Actually, even if the function is not one-to-one, the axis of symmetry is still y equals x. However, the inverse would not be a function. So that's everything for graphing inverse function. I hope you learned a lot today, and see you guys on the next video.